Okay, so we're just going to see how long it takes me to work through this worksheet. This is so if you wanted any commentary on the solutions, obviously I'll post just the plain PDF up as well. So we're starting right here with this first circle one, and these first few are not trick questions. Name of circle P, that's just circle, or center P. I guess technically, if we're going to name the center, we should say point P. Yeah, not a trick question. We can see that easily from the picture. We can see that easily from the name as well. Radii of the circle must start at the center and go to an endpoint. So you've got options of PA, PD, and that last one right there, PB. Those are your three radii. Your diameter must go through the center. So you have a diameter of AB, and then name two chords. They must have endpoints on the circle, so AD is one of them, and then the other one was our diameter AB, and those are our two chords. We want to find the circumference of the circle with a radius. I know this says nearest tenth. My preference is still going to be for you to leave pi in your answer. So I'm just going to say that as a general rule right there. So 2 pi times our radius. So 2 times our radius, we've got 6 pi for our circumference. 2 times our radius, we got 4 pi. I guess we should keep the units there, centimeters. 2 times our radius, that's going to be 68 pi millimeters. And then that one right there becomes 9 pi meters. So multiplying by 2, not that bad. You come down to, ooh, and I forgot to move it up. Whoopsie. Well, I'm just going to keep going for it because why not? So then we come down to the next part, so I'll leave that there for just a second. You're multiplying by 2, that's not too bad. So then we come down here, and it specifically does ask for exact answers, and the trick here is we have to do a little work to find our circumference. If my diameter is 14, then that means my radius is 7, but 2 pi r, I'm just multiplying by 2 anyways, so our circumference is going to be 14 pi. Going over to number 10, this side right here is 10, this side right here is 24, so if I'm going to find my diameter, I've got to use Pythagorean theorem. 10 squared plus 24 squared equals my diameter squared. I want to say that's like 25 or 26, but it's early and my mind isn't thinking just yet. I think it's 26. 24 squared plus 100, 676 square root, yeah, it's 26. Hey, I almost knew it. So our diameter is 26, which we could turn into our radius, or we could just slap our pi on there. 26 pi centimeters. I guess I should have added inches over here. Same thing over here, I've got 5, exact answer. Do you recall that this is going to be a special kind of triangle since it's isosceles and it's 45, 45, 90, and that's one of our special right triangles. And go see if you can find the blueprint and realize that without any work, we know that our diameter must be 5 root 2. So now I'm right here, I've got 5 root 2 pi. Here's the deal, if you write this, be very careful that the pi is not underneath your square root. This would be okay. I've put a little space in there. It's also acceptable to put the pi in front of the square root so there's no confusion. What you want to avoid is you're writing really quickly and your answer kind of looks like this. Because if your answer looks like this, is the pi under the square root? Is it not? I don't know. So just be careful and make sure your notation is neat and the pi is clearly outside of the square root. So I'm just going to put that right there. So then I come over to 12. Oh look, 30, 90. Guess what? It's probably a 30, 60, 90. Oh look, another blueprint. So if I'm looking at this one right here, 30, 60, 90, 8 root 3. You might remember the blueprint has a x root 3, an x, and a 2x as your ratio of sides. So if 8 root 3 is equal to x root 3, well then x must be 8, in which case this side over here is 8 and this side over here is 16. So at that point you've got your diameter of 16, throw your pi on there, your centimeters, and you are done. And that is page 1.